Hello everyone. In today's tutorial, we'll be learning about another machine learning technique known as random forest. Random forest is a machine learning technique that's used to solve regression and classification problems. It utilizes ensemble learning, which is a technique that combines many classifiers to provide solutions to complex problems. A random forest algorithm consists of many decision trees. The forest generated by the random forest algorithm is trained through bagging or bootstrap aggregating. Bagging is again an ensemble meta algorithm that improves the accuracy of machine learning algorithms. The random forest algorithm establishes the outcome based on the predictions of the decision tree. It predicts by taking the average or mean of the output from various trees. Increasing the number of trees increases the precision of the outcome. A random forest eradicates the limitations of decision tree algorithm. It reduces the overfitting of the data sets. And as we had discussed earlier, overfitting and underfitting is something that our algorithm should avoid, and it increases the precision. That is something that we want. Now it generates predictions without requiring any configuration in packages. So before understanding the working of random forest, we must look into the ensemble techniques. Now the ensemble word simply means that we are combining multiple models. Thus, a collection of models is used to make predictions rather than an individual model. Now, there are two ensemble techniques which you can see over here. One is bagging and the other is boosting. Now, bagging creates a different training set. It creates a different training subset from the sample training data with replacement, and the final output is based on the majority voting. So as we had even seen Canaan, that there is a criteria of majority voting over there too, right? Now for example of bagging is random forest. Thereafter we have boosting. Now it combines weak learners into strong learners by creating sequential models such that the final model has the highest accuracy. Now, examples of boosting are XG boost, ADA boost, all of these are examples. Now, let us learn about bagging because that is something our random forest classifier is using. Bagging, also known as bootstrap aggregation, is the ensemble technique used by random forest. Now, bagging chooses a random sample from the dataset. Hence, each model is generated from the samples provided by the original data with replacement known as row sampling. Now, this step of row sampling with replacement is called bootstrap. Now, each model is trained independently, which generates results. The final output is based on majority voting after combining the results of all the models. Now, this step involves combining results and generating output based on majority voting, known as aggregation. So, as you can even see in the image, we have the original data. Thereafter, we are bootstrapping it. We are learning the decision tree classifier. We are aggregating the outputs of each classifier. We are bagging them. And thereafter, we are getting the final outcome. So if we come down to the steps of random forest, and we'll take that using an example. Now, the first step is that in a random forest, n number of random records are taken from the data set having k number of records. Step 2 is individual decision tree are constructed for each sample. Step 3, each decision tree will generate output. And step 4, final output is considered based on majority voting or averaging for classification and regression respectively. Now, for example, you consider this fruit basket as shown in the image. Now, n samples have been taken from food basket and an individual decision tree is constructed for each sample, which was a step 2. Now, each decision tree will generate an output, which is a step 3, and step 4, which is aggregation of all the outputs. So, the majority that we see over here is saying class A, and that is why the final outcome is of class A. Now, let us move forward to the code and understand all that we theoretically discussed. We'll be first of all importing all the necessary libraries. Thereafter, we have taken the data set of heart disease to predict that what will be the heart disease. Now, one of the very important example or application of ensemble of random forest generator is in healthcare e-commerce. So we have taken the example of healthcare. Now, there are various attributes that you are able to see over here. CP is chest pain and it has 4 different values. Thereafter, we have resting blood pressure. Then we have serum cholesterol. Then we have fasting blood sugar. Then we have resting electrocardiographic results and various different features that are required to find that what type of heart disease or predicting the heart disease, right? So this is our data. Thereafter, we'll be splitting our data into train and test values. And thereafter, we are calling a random forest classifier. Now, let us see that what are some of the important hyperparameters that we have over here. Now, hyperparameters are used in random forests to either enhance the performance and predictive power of models or to make the model faster. Now, the hyperparameters to increase the predictive power is first, which is over here, which is called n estimators. Now, n estimators, number of trees the algorithm builds before averaging the predictions. Thereafter, we have max features. So max feature, this attribute says the maximum number of features random forest considers splitting a node. And thereafter, we have mini sample leaf, min sample leaf. So min sample leaf determines the minimum number of leaves required to split an internal node. Now, the hyperparameters which increases the speed is, first of all, it is njobs. So njobs tells the engine how many processors it is allowed to use. If the value is 1, it can use only the one preprocessor, and if the value is -1, then there is no limit. Thereafter, we have random state, which we have even said over here, which is 42. Now, this controls the randomness of the sample. The model will always produce the same result if it has a definite value or random state, and if it has been given the same parameter and the same training data. Next is a very important one, which is the OBB score. OOB score. Now, OOB means out of the bag, since we are using the bagging ensemble technique. Now, it is a random forest cross-validation method. In this, 1/3 of the sample is not used to train the data, instead used to evaluate its performance. So these samples are called out-of-bag samples. So we have kept OOB score as true. This is our n estimators, max depth, different things, and this is the rest of the documentation that you can go through. Now we'll be fitting our X train and Y train data. And as we just discussed, we'll be seeing that what is our OOB score. So our OOB score is coming down to 80%, which is quite good. Now moving forward, so let us understand that why is random forest important over decision tree. So firstly, it's more accurate than decision tree algorithm. It provides an effective way of handling missing data. Then it can produce a reasonable prediction without hyperparameter tuning, and it solves the issue of overfitting in decision tree that we had seen. And in every random forest tree, a subset of features is selected randomly at the node splitting point, right? So that's all for random forest.